An equation with one or more radicals containing a variable is called a radical equation. To solve a radical equation, you should do the following. First, isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. Second, raise each side of the equation to a power equal to the index of the radical you have isolated. Third, solve the resulting equation. And fourth, and it is mandatory, check the potential solutions in the original equation. If one or more of your answers do not check out, it's called an extraneous solution and must be discarded. If you do not do step 4, there's a chance that the answer you get may be wrong. So you have to do step 4. You have to check and see if it's true. So let's start with ours. Square root of 2x plus 1 plus 5 equals 8. So we're going to see that we have one radical and we're going to isolate it. So I'm going to take this 5 and I'm going to subtract it over. So I'm going to get square root of 2x plus 1 equals 3. And this has an index of 2, so I'm going to square both sides of my equation. And when I do that, the square root and the square cancel each other out, leaving me with 2x plus 1, and then 3 squared is 9. Now I can solve for x. So I'm going to subtract 1 over, so 2x equals 8, and I'm going to divide by 2, so x equals 4. Now, is this a solution? I don't know. Let's find out. We're going to take 4 and plug it back into the original, see if it's true. So, square root of 2 times 4 plus 1 plus 5 equals 8. So 2 times 4 is 8 plus 1 is 9. So square root of 9 plus 5 equals 8. Square root of 9 is 3 plus 5 equals 8. And 8 equals 8, which is true. So I can say that x equals 4 is a solution. Next I have 8 plus square root of x plus 2 equals 7. So I'm going to isolate my square root. So I'm going to subtract 8 from both sides. So I'm going to get square root of x plus 2 equals -1. And again, I have an index of 2, which means I'm going to square both sides. And when I do that, the square root and the square cancel, leaving me with x plus 2. And -1 squared is going to give me a +1. Now I'm going to subtract 2 over, and I'm going to get x equals -1. Is this a solution? Don't know. Let's take -1 and plug it in for x and see. 8 plus square root of -1 plus 2 equals 7. -1 plus 2 is going to give me a +1. So 8 plus square root of 1 equals 7. Square root of 1 is 1, so 8 plus 1 equals 7. And 9 equals 7. 9 does not equal 7. Nope, not at all. So x equals -1 is not a solution. And since I have nothing else that I solved for that I got an answer, I can say that there is no solution to this equation. Last, p plus 4 equals p plus 6. I have my square root already isolated. So p plus 4 equals square root of p plus 6. And since this has an index of 2, I'm going to square both sides. And the square root and the square will cancel out. And I'm going to end up with p squared plus 4p plus 4p plus 16, because this FOILed out, equals p plus 6. Combine like terms, p squared plus 8p plus 16 equals p plus 6. And I'm going to solve for p. I'm going to move p and 6 over so I can get all on one side as a quadratic. So p squared, subtract p over, 7p, subtract 6 over, plus 10 equals 0. And if I factor this quadratic, I'm going to get p plus 5 and p plus 2 equals 0. Now I'm going to set both of these individually equal to 0. So p plus 5 equals 0, p plus 2 equals 0. So p equals -5 and p equals -2. So again, are these two solutions? Let's plug it back in and find out. So first one, -5. So -5 plus 4 is equal to square root of -5 plus 6. So -5 and 4 is going to give me -1. -5 and 6 is going to give me +1. And square root of 1 is 1. -1 does not equal +1, so it's not true. So I can get rid of this as a potential solution because I know it's not true. Now what about -2? So -2 plus 4 equals the square root of -2 plus 6. -2 plus 4 is 2. -2 plus 6 is 4. And square root of 4 is 2. And 2 does equal 2. So this is true. So since -2 plugged back in gives me a true statement, p equaling -2 is our solution to this radical equation.